Welcome to the Copper Spice YouTube channel, and thanks for joining us. Most of us assume variable declarations are simple. We want to show a few examples where this falls apart. Declarations gone wrong. We have realized that declarations in C++ can be viewed in two unique ways. One direction is based on how programmers design and write the code. The other angle involves how the source code is parsed by the compiler. We are going to show what happens in both of these situations and why this information may change your choices about how you write a declaration. Several examples will be provided, including how to correctly declare a variable inside an if statement.
When a programmer is writing a variable declaration, the idea is to define the data type and a variable name. Our first declaration creates a variable named count, which has the data type of int. The second declaration establishes the variable named ptr with a data type of pointer to int. By knowing that count is not a pointer, it is obvious that no code will try to dereference the variable. This approach is very natural for programmers, since the data type defines how the variables can be used in subsequent code. Now let's look at how the compiler actually parses a variable declaration. The C++ standard defines the grammar of a declaration, and by definition it contains two elements. The first part is the declaration specifier, and in both of our examples this is an int, which is in the category called simple type specifier. There are other declaration specifiers for variable declarations, including storage class specifiers, type specifiers, simple type specifiers, constexpr, and a few others. The specifiers are listed as a sequence of whitespace separated tokens, which can appear in any order. The const and volatile keywords are examples of a CV qualifier, which also falls in the category of type specifiers. There are also other simple type specifiers, including char, int, bool, and void. The second part is called the declarator, which contains the variable name. What is surprising and interesting is the symbols like an asterisk to indicate a pointer or square brackets to indicate an array are part of the declarator. In our first example, the declarator is simply the identifier, which is the name count. In our second example, the declarator is the combination of the star and the identifier ptr. In our source code style guide, we have a rule about where the star needs to appear in a pointer declaration. We always put the star next to the identifier, since it is part of the declarator.
Multiple variables can be declared in a single statement. The code shown in Block A is equivalent to the code in Block B. Using our knowledge of declarators, we can look at this example and now describe why it works the way it does. Looking at line 1, the declaration specifier applies to every identifier. Both of our variables have the simple type specifier of int. The first identifier is tiger, and the second is swan. Remember, the star is only part of the tiger declarator, which means tiger is a pointer to an int. The variable swan is simply an int. The same behavior would exist if we were declaring an array or a reference. The brackets and ampersand are part of the declarator, not the specifier. It is a common practice to save values, like the size of a container, to a temporary variable. Then in the test condition of an if statement, we use the variable, as shown on line 2. Storing the size to a variable improves readability and can be a small optimization if this value is required within the body of the if. A new form of the if statement was added to the language in C++17. Now we can merge line 1 and line 2 into one statement, as shown on line 3. Initially, we did not care for the syntax and found it rather awkward. After looking at this again, we discovered this newer syntax is simply the first 2/3 of a for statement. This observation has changed our opinion about embedding the declaration of count into the if statement.
Here we have a function which shows a full example of an if statement with an embedded variable declaration. The initialization will occur first, and the variable count will be set to the value of 3. The condition expression, or test, happens next. Since the value of count does not equal the integer literal 25, the else branch will be taken. The message false will be printed, along with the value of count, which is of course 3. Notice that even though the variable is declared in the if statement, it is still in scope in the body of the else block. This code is slightly different from the previous example. We made a few minor changes to line 2. Read the if statement carefully. What do you think this function will print? Notice there is no semicolon between the variable declaration and the conditional test. Now we are no longer using the C++17 embedded declaration syntax. So how does the compiler unpack the if condition? Everything on the right side of the equal sign must be evaluated before the variable count can be initialized. So the first part of the process calls the method size, which returns 3. The next step is to compare this return value with the literal 3. Since 3 is equal to 3, the result is the Boolean value true. Now we can initialize the variable count, but we have a Boolean and we need an int. So the true is converted to the integer value 1. Finally, we now know that count is initialized to 1. But to test which branch of the if to take, the variable count needs to be converted back to a Boolean. The end result is the true branch is taken, but the printed value is 1. This is probably not what you initially expected, and most likely not what you wanted.
We showed a prior example which declared multiple variables using 2 declarators in one statement. Here is an example which pushes the envelope. It turns out there is actually no difference in the syntax between variable declarations and function declarations. We can declare multiple functions in one statement as long as their return type contains the same specifier. The first line of this example declares 2 free functions. The function location has no parameters and returns a pointer to an int. The function cost accepts a Boolean and returns an int. We did not really expect this code to compile, but it does, and it works. Even though you are allowed to write code like this, we strongly urge you to reject this in a code review.
For more information about the CopperSpice project, please visit our website at www.copperspice.com.
Thanks for watching. We hope you found the content of value. If you have any questions or feedback, feel free to leave a comment on this video or send us an email.
Please make sure you subscribe to our YouTube channel and come back for our next video.